Welcome and hello. This is a HEC RAS support video. And what I'm going to talk about in this video is ineffective flow areas. Specifically, what does it mean for an ineffective flow area to be permanent? And how is that different from a non-permanent ineffective flow area? All right, so to give a quick answer, permanent ineffective flow area is an area of the cross-section that will never convey flow. And if it's not permanent, then that means that that particular area will not convey flow until the water surface elevation exceeds a certain set threshold elevation. So we're going to go ahead and demonstrate that in this video tutorial. I will leave a link to this page here where it talks about ineffective flow areas and how to set them to permanent, but it doesn't actually give a demonstration. It just kind of describes it briefly. And this video is your demonstration. All right, so what I have is HEC RAS open. I have my geometric data editor open as well. And this is my geometry file. I have two cross sections. They are at River Station 0 and River Station 1000. Here is the main channel. We're going to focus on this upstream cross section at River Station 1000. Here's the main channel, and then here's the bank line point locations, and then here's the right over bank, and then the left over bank has a channel as well. So this is already built out, ready to go. I'm going to run the simulation and show the results. Real quick, I'll go ahead and demonstrate the flow hydrograph as well. So the flow rates are going to range from 500 CFS up to 2500 CFS, and then come down back to 500, 2500, and then 500. It is a 24-hour simulation with a 1-minute computation interval, and there's also a warm-up period. So let's go ahead and run that. Oh, never mind. It looks like I deleted my plan data. So let me go ahead and do that. File, save plan data, left channel. That's what I want to call it. Okay. Okay. I'm going to be running all three of these processes, and I need to set the start date. Okay. So it's a 1-minute computation interval. For the output interval, I'm going to change this to something a little bit smaller, maybe 20 minutes, just for a little bit more precise results. And I think we're good there. So file, save plan, and compute. Okay, we're done now. Let's go ahead and take a look at some of those results. Here is the cross-section view right here. I'm going to click on the play button to bring up the animation play bar, and then just click the play button. The water surface increases as the flow increases, and it also decreases as the flow decreases. All right, so nothing too exciting there. What I'm going to do now is create two more geometries, and they will both have an ineffective flow area, specifying this left overbank as ineffective flow. The first one will be non-permanent, and then the second one will be permanent. So I'll set a threshold elevation for both of those. All right, so what I'm going to do is go back to my geometric data editor. This is called left channel. What I'm going to do is go File, Save Geometry Data As, and then I'm just going to go _IFF, and then OK. And then I'm going to open up the cross-section data editor, and I'm going to put my ineffective flow area right here at the left overbank, station 60. So options, ineffective flow areas. It's going to be 60. And then as for an elevation, let's see, 41. Let's just go ahead and make it 42. So it's 1 foot above the bank. And I'm going to leave this permanent checkbox unchecked this time. All right, so click OK. And then click Apply Data. Next, I want to add a ineffective flow area to the other cross-section. That's the upstream cross-section. So I'm going to go up to Options, Ineffective Flow Area. This is, again, cross-section, station 60. And now the elevation is going to be 42. Okay, and then Apply Data. That looks good. I'm going to go ahead and close that. File, Save Geometry Data. Now, while I'm editing geometries, I'm going to add one more geometry file. The only difference is going to be that permanent checkbox for the ineffective flow areas on both of my cross sections. So I'm going to go File, Save Geometry Data, and then I'm going to add another suffix of PERM for permanent after this IFF, and then click OK. Cross sections. Okay, so this is the cross section at River Station 0. Options, Ineffective Flow Areas, and then I got to check on this permanent, and then click OK. Let's go up to the other cross section here at River Station 1000, options, ineffective flow areas, and permanent, and OK. There are a few other ways to toggle on the permanent or non-permanent checkbox. That was one of them. The other is if you go up to Tools and then Ineffective Areas and then Set to Permanent Mode, you can go ahead and use this dialog box to do the same thing. All right, let's go ahead and create our plans now. I'm going to go to Run and then Unsteady Flow. This is currently using the left channel ineffective flow permanent geometry. So that's fine. What I want to do is the file, save the plan as, and then I'll just click on left channel and say IFF PERM. Okay, copy that and then click OK. Use the same thing for the short ID and OK. And then click on the compute button. Okay, that's successful. And we still need to run the ineffective flow plan that uses the ineffective flow geometry that is not permanent. So let's go ahead and make that change. You want to save the existing geometry data. Yes. Okay. And then save the plan as, and I'm just going to delete PERM. Okay. And then I'll use the same thing here for the short ID and okay. All right. So we're saved and ready to compute. All right, and close. Let's go ahead and take a look at some of those results now. Let's just go to view and cross sections, I think would be a good place. I'm going to go up to options and then plans, and I'm going to toggle on all three plans here. So we have left channel, that's no ineffective flow. Then we have left channel ineffective flow permanent and left channel ineffective flow non-permanent. Okay, I'll go ahead and click OK. Now we have three separate lines here. I'm going to animate the playback of the simulation and then step through the time steps. So I'm going to click on this play button here. It brings up the animation control toolbar. And then as you can see over here in the legend, we have the three different profiles. Of course, the animation just began, so there's really nothing to look at. And I probably do need to zoom in a little bit. So I'm going to go right click, zoom in, and then just focus in on maybe this area right here. Okay, I'm going to start clicking through the time steps now. And it looks like, let's just go back right here. Already, we see a slight separation in water surface elevation between the left channel plan right here, which is conveying flow through this left channel. And then the other two, if I click on it, this is left channel ineffective flow and left channel ineffective flow permanent. Those are both at the higher water surface elevation because 100% of the flow needs to be conveyed through the main channel, not through this left channel, as I'm calling it. Next, what I'm going to do is advance the timeline a little bit further until the water surface exceeds this 42 foot mark. So let's just go ahead and click, 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 and then boom. Okay, so right here, this is a time step of particular interest of mine. It is 3 a.m. And now we can see three separate lines here. I'm going to zoom in just a little bit further because even I can't see it that well. There we go. So the bottom line will always be left channel, and then the top line will always be ineffective flow permanent right here. But it looks like the left channel ineffective flow plan right here is no longer the same as ineffective flow permanent because the water surface has exceeded 42 feet and it is in the process of converging with the main left channel plan water surface elevation. And the reason why it isn't instantaneous is possibly just because of the hydraulics of it all. Keep in mind, this is just fractions of a foot. We're at 42.2 here, 42.4. So this is probably just a matter of inches anyway. But if I advance the animation playback a few more time steps, I think those two will converge. So let's go ahead and see what happens. Yes, I got to zoom out now. Yes, it looks like it converged. So let me just replay the whole animation here, at least the point of interest. So right here, we see three different water surface profiles, and then boom, back to two. And at this point, left channel IFF and left channel are the same. And then left channel IFF permanent is the higher water surface elevation right here because it permanently cannot convey flow through this ineffective flow area. All right, well, that is it for this support video in HEC RAS. Basically, to sum things up, if the ineffective flow area is permanent, it behaves more like an obstruction. It never will convey flow. However, obstructions do not contain water, whereas ineffective flow areas still contain water. They just don't convey water. The normal, non-permanent ineffective flow areas will convey water as soon as the water surface elevation exceeds that set threshold elevation.